Hi, I'm Frederik. I'm part of the experimental media research group. This is Rémi, will introduce himself in a bit. We're a research group connected to St. Lucas in Antwerp, in Belgium. We create an application called NodeBox that allows us to create generative designs through a node-based approach. And here's what it looks like. So here we can see an application on Mac that creates a data visualization in a very visual way. There's no programming involved or whatever. This is what we teach to our students.
Hi, I'm Rémi. I'm the first developer of Prototypo. Prototypo is a type design application for graphic designers where they can customize parametric fonts and make them their own. So it's another automatic type design application, and I'm happy to announce that we now have a specific spacing feature in the application.
Back to NodeBox, we're an open source application, and we test it very often, especially with students during workshops. For example, for making data visualizations or generative types. Here we see a visualization created in the application by 2 graphic design students from Lithuania during an introductory NodeBox workshop. This was about the Eurovision Song Contest, and here you see a detail. Here's another one, also from the same workshop in Vilnius. They're showing the most commonly used words throughout 50 years of film speech. So if we look at a detail, you can see that it has things like the popularity of the word gun over time in popular movies, or the word mom or pop or dad, things like that. One of the strengths of NodeBox is that it's not linked to specific static chart types. So that means that everybody can create their own chart type. In this case, because it was about speech, they wanted to use a sound wave to reflect that type. And that's okay, we support that. NodeBox also has extensive support for working with fonts and accessing the shapes of the glyphs. For example, we can draw random lines between them. We can place shapes on the letter forms. Thanks. We can snap them to an invisible grid. We can create these soft, wavy shapes, or basically anything we want. Now, we also do these experimental typeface design workshops, where in 1 week we ask students to create an experimental typeface. The thing is here, it's really experimental. That's the basic idea. So one of our students made an evil font, and the fact that it's evil is because it has an evilness slider. So back before we saw the OpenType font variations, we think that this should be one of the axes that should be in every font, evilness. And so it goes from 0, and as we increase the slider, we get a little evil, a little bit more evil, more, until we reach mega evil. So for this to work, of course, we need to have access to the shapes of the glyph. We need to be able to see where we can place all these elements on. So all of the examples you saw up till now were made using NodeBox 3, which is a cross-platform desktop application. It's open source. And there we can use the font APIs to access the glyph outlines. We do this through Java. Now, a couple of years ago, based on feedback by users, we started porting the application to the web because they wanted to show these things on the web. They wanted to present them. And this screenshot shows a bit what outdated version of NodeBox Live. That's the version that's running on the web, and that will be available later as an open beta. Right now we're testing with a lot of workshops and students. But unfortunately, this is the web. There's no good API in the browser to access this information. Sure, we have web fonts, and we might get some way to find the metrics. There's no way to get the actual glyph shapes of the type. So I searched around, I posted on Stack Overflow, but I couldn't find any answers. And that's why we decided to write my own library. So the Otf Font, we heard a lot about it. As you know, it's a binary font. This is what it looks like. And it contains a number of tables, which we talked about, each in a binary format. So all the tables have a specific function, and we have to have a way to take this binary data and convert it to actual table structures. And on the web, we use typed arrays for that. So there are some facilities there that we can use and that we leverage. Array buffers are one, typed arrays, and then the data view object is also really big. And that allows us to transfer this into something that we can work with that looks like this. So this is OpenType.js, or the homepage of it, at least. So it's a library for reading and writing TrueType or OpenType fonts on the web. And because it's a library, it serves as a base for other applications. We try to make this as good as possible so the implementation is okay, but also that there's documentation, that there's ample examples. And one of the things that we did is we made something like the Web Tools Inspector in Chrome, for example. We made that for fonts as well, so you can inspect your font and see if everything, all the data is there, and if it's correct. So let's talk about how we can use this library. So you just include a script tag, or use a package manager like npm browserify, and then you call opentype.load. So this is all JavaScript code, right? Then that goes over the network, and it requires a callback function when it's done loading. And that function first checks for an error, and then it can do something with the font. Here, for example, it could take the font, get a path from that font, say, okay, this is Hello World, it's at this position with this font size. Now do something with the font. This is a path object at that point, so animate that path, and then you can draw it on a canvas tag, or you can convert it to an SVG and start working there. So it's intercompatible with all the web standards. That's on a font level, so that's the API there. You can also dig deeper and look at, for example, the conversion from strings to glyphs, because there's not always a one-to-one mapping. And that gives you a list of glyphs, and then from these glyphs you can also access individual information. A lot of cases that you would access the path or you would access the metrics to get this information. And then you can manipulate entire fonts. For example, here you can say, okay, load a font, then for each of the glyphs, call this transmogrify function, whatever it does, and then download that font. So make a new font that actually downloads onto the user's computer and that he can install. The example you see here is one that I did during Codevember, which is a coding challenge. And I developed a very simple interpolator that just took two fonts, did a linear interpolation between the points. And then you can download the new font. Now, obviously this is a toy, but the thing that we wanted to prove is that it's quite easy to do with very little code. And then you can also create fonts from scratch. So to do that, we just draw each shape any way we want. And then, so this creates a path. We do move to line to constructions, things like that. Then we convert that into a glyph with some extra metadata, like the name of the glyph, the Unicode quote point, the width, and the path, of course. And then we do this over and over and over again. And then we have a font object that we construct with a family name, style name, the units per m square, of course, ascender, descender, and then the list of glyphs that we provided. And then when all that's done, we can work with that font. So we could actually directly install it in the browser, which we'll see in a minute, or we can download it again to the user's computer. So this allows for, and yeah, there's a higher level API that Rémi will talk about. So all of these features actually enable a lot of interesting things that we can do with fonts. Not just by reading the fonts and working with them that way, but also by having tools that actually create fonts from scratch or from somebody else. And that's where Rémi will talk about.
So in 2013, we built the first web version of Prototypo. the very initial prototype used to render text as vector shapes on the screen and to export SVG fonts. That meant that users couldn't interact directly with the text inside the application, with the fonts we created inside the application. They couldn't just point and click and delete text or add new characters or copy-paste. And before using their fonts, they needed to convert them from SVG fonts to TTF. That wasn't great, but that was just a prototype. And then soon enough, we discovered OpenType.js. So we got in touch with Frederik, and we asked him if he would be capable of adding the features to export, not just read Otf fonts, OpenType font, but to export them, and if he was interested in doing that. And he answered yes to both questions. And so in a few months, we had a working version of OpenType.js that was able to export font. And we combined that version of OpenType.js with Paper.js, which is another JavaScript library. It defines itself as the Swiss Army knife of vector drawings on the web. And indeed, it can do pretty amazing things with 2D drawings. It can apply matrix transformation, like rotate shapes, scale shapes. It can combine shapes, for example, not only combine, but also make shape exclusions to take two disks of different sizes and to pierce one into the other to create a disk or an O letter. And it can work with Bezier curves in any way imaginable. So those features are something that are easy to use in your favorite design application, but when you search into the math behind those operations, it's quite complicated. So we're happy to find a library that already had that, and then we combined OpenType.js with Paper.js in a matter of weeks, and we created Plugin.js, which was higher level and highly capable API to read and create fonts on the web. And so so it's comparable with RoboFab, the RoboFab API, if you've already used that. So the first thing I did with Plugin.js was this very little demonstration. And in few lines of code, I used the built-in basic geometric shapes like triangles, and I combined two triangles to create an A, and then four squares to create a B, where you have two large squares and two smaller squares that are used to pierce the holes of the B, and same thing for the C. So I did like in no time, in like 60 lines of code, and then I tried to use the features of Paper.js to transform those shapes and to rotate those shapes. And I wondered if it would be possible to do that actually fast enough to be able to animate those rotations. And so that's what is demonstrated in this GIF. So what you see here is Plugin.js being used to not only create a font with very basic geometric shapes, but the font is created inside the browser and loaded dynamically inside the browser, fast enough, like 30 times per second, that you have the impression that the font is animated. And it's not just a vector animation, it's a real font that is produced in the application. So that can be used to do pretty ugly designs, I guess. But that also has some practical use, which we'll see later. And the second demonstration is similar to what Frederik just showed. So here we used both the reading capabilities, the reading and writing capabilities of OpenType.js to read two OpenType font in the browser and then generate in real time a new OpenType font that is loaded again dynamically in the browser. One thing I forgot to say about loading a font dynamically in the browser is that it's currently only possible in Chrome and Firefox. I think it has been added recently in developer builds of Safari, but you can't just load the font with inside CSS, with normal CSS. That's not fast enough. So anyway, that demonstration was built in 2013, so a few years before the OpenType variation was announced. And once we had plugin.js, we used it inside Prototypo to power our parametric fonts and the entire application. So the benefit here was that not only we were able to produce an application where you can interact directly with the fonts that are generated, and that is able as well to output to export OpenType font, but another benefit of being able to load the font to generate and load the font directly in the browser is that we are targeting graphic designers, and as you know, type design is a discipline with a very specific terminology, and we cannot ask our users to learn the terminology before using the application. So the good thing here is that they don't need to know what aperture exactly means. They can just try modifying the aperture and see in real time what it does on their font. So the next example of usage of OpenType.js is FontSelf. FontSelf is a plugin for originally Adobe Illustrator, but they're about to announce a plugin for Photoshop. It's a French team, so we know them well, and it's a plugin that allows designers to create fonts, to design fonts in tools that they're already familiar with, and then export functional OpenType fonts. And FontSelf is an interesting example because it's the first commercial use of OpenType.js outside of a browser. There are now more and more applications that provide JavaScript as a scripting language, and the FontSelf guys were able to leverage that possibility and to integrate OpenType.js and build a working commercial product in less than 6 months. They had to do a little bug fixing on OpenType.js that they contributed back to the library, and they are now committed to bring more features to the library. The next tool that I'd like to present is Metapolator. I need my notes here. So Metapolator, as stated in their product vision, is an open web tool for making many fonts. It supports working in a font design space instead of one glyph, one face at a time. And here you can see that OpenType.js is used in a tool that's meant primarily for professional type designers. There is a talk later today about Metapolator, so I encourage you to attend to learn more. The next example is Glyphr Studio. It's a more traditional type design application where you start with a blank page and a pen. It's an online application as well. It's free, it's open source, it's actively being maintained, and of course it uses OpenType.js. So what's cool about all of these applications built on the web is that the web enables new connection between applications. In less than a day, I was able to build a bridge between Prototypo and Glyphr Studio. And you can now in one click, export your font from Prototypo and then rework them, refine the design in Glyphr Studio. Now, NType is a much more experimental application. It's a tool that is able to load a font and then achieve a 3D extrusion and create meshes from a simple font, then animate it on different axes. And you can, of course, export the very weird shapes that you see on the screen as a font. So I think it's an interesting example because it shows that there are developers willing to tinker with fonts and that are not necessarily familiar with the tools that have been used so far to create fonts, mainly Python. And so it brings a new pool, I'd say, a new pool of talented developers willing to play with fonts. I think that's That's good. The next 3 tools are also very interesting because they make the connection from the digital world back to the physical world. The first tool is Maker.js. It's a Microsoft Garage project. And it's an online tool and library to create parametric 2D drawings designed for CNC and laser cutters.
The next tool, the next one is from Belgium, so that's why I'm obliged to talk about them. That's a company called Twikit who makes customizable 3D printed shapes, and they make these customizers where they allow you to do things like, for example, make a 3D trophy. So they have a web interface where you can do 3D trophies. You can set text, this is all for non-experts. And the live preview is actually done in OpenType.js combined with 3.js to have the 3D effect, so you can spin it around and things like that. Another one is they made this for necklaces. So if I ever want an OpenType.js necklace, then I can order it here, or you can order it there if you want to. And also, you can spin it around, you can see how it looks. It sort of has this shine that reflects, so you can sort of see how it's going to look in real time. And of course, you can type in your phrase and immediately see it update. So those are really interesting ways of taking in this part, the reading part, and taking that back into the real world and saying, okay, this is a web tool, but it eventually will become a real object. Then something about P5. Who here is familiar with P5? Nobody? Okay, so who's familiar with processing? Okay, a couple of people. So P5 is like the JavaScript sister project of processing. Just as processing, the goal is to make code accessible for non-programmers or beginning programmers, artists, designers, educators. It was developed a couple of years ago by Lauren McCarty, and it can be compared a bit with Drawbot and NodeBox 1. What's interesting here is that I actually discovered that P5 was using our library by accident. They didn't tell me. I was in St. Lucas giving a code studio, which is a platform where students can come and ask questions. And one of the students was playing around with P5 and had a problem with her fonts. And I looked at the web inspector to see what the error was, and I recognized my own code, and I said, oh, I have to fix it. So it's funny that they use it as well. Here's a very small example of how they use it as a snapping filter. So the software is now at a point, I think, where we can load and save fonts reliably and use the basic features of the fonts. But we have some ideas and things we like to add in the future. The first one on the list is ligatures. I think there's currently an implementation. I don't think there is actually an implementation of some OpenType features like G substitution, both reading and writing. But the system is quite low level and it's not generally usable for non-experts. So I should say that we have these multiple levels of API, so you can go like at a high level, ask it to get a path and then work from there, or you can drop down into the table, see which tables are being written, and then sort of mess about and then export that as well. So we have that low level part, we don't have the upper level part yet. Same thing goes for contextual alternates and support for simple kerning using gpos. We already support the current table, the old school current table, we don't do gpos yet. And then we heard about color fonts this morning. So there's a lot of standards. Because this is a web tool, we hope the SVG in OpenType will win, because then it's on the web and SVG is already there. So less work for us. And then also this morning you heard about font variations, or OpenType.js, as I thought it was going to be called. We had some work done by Sasha Abrauer from Google, who was doing an initial implementation of FRs tables inside of OpenType.js. I think it still runs a bit behind the current spec, so we will have some work to upgrade it to the newer version. But in that case, you will be able to use font variations also in OpenType.js. You want to talk about the challenges?
Yes, so there are already many things that you can do with OpenType.js to export OTF fonts, but there are still some challenges if you want to build font creation tools on the web using JavaScript. And these challenges mainly have to do with the inavailability of many production tools that are that you're familiar with in the Python world. So mainly here I'm talking about TTF AutoHint, font tools, and the Adobe FDKO. So these tools will probably never be converted manually to JavaScript. There might be some hope to convert them automatically from Python to JavaScript. But the short-term solution, the workaround that we are using in Prototypo, is to have these open source tools hosted somewhere on a server and exposed remotely through an API. So you can host those tools and then send your font to those hosted tools and get back a font with auto-hinting and with overlapping shapes removed and stuff like that. That's what we are doing.
So I also wanted to include a useful list in case anybody else feels like writing a JavaScript parser for fonts. These are the things that really help me, and I think a shout out is needed. PDF.js by Mozilla, which also contains a font parser and font writer. TTF.js, which was the first one that I encountered. CFF Glyph fonts by Mike Cameron, which was super, super useful. Also his discussions with him. FreeType for when the spec and the actual implementation were not really talking the same language. That was very useful. TinyInflate, which is the only dependency we actually have in OpenType.js to decompress WAF fonts. And of course, the specs by Microsoft and Adobe for writing this. And then, of course, last but not least, I'd like to thank all the amazing contributors who have helped me with the project. This is insane. So I started the project 2 years ago. I put it on GitHub, did a tweet, and I had, within a half hour, I had a pull request from somebody who saw it, downloaded it, looked at it, found something to improve, and then posted it back on GitHub. Useful code in half an hour. So that was completely amazing. It still blows my mind. And I've had so much support in working with this. So that's very humbling. So I wanted to thank everybody who's part of the community and who has helped in doing this project. So that's it, I think. Check it out and let me know or us know what you built with it. Thanks.
We have time for one question. Does anyone have a question?